What are these sizes like? These are in microns, or millionths of a meter. Micron is barely visible with a light microscope, about the size of a fairly typical bacterium. Viruses are even smaller than that. So our condensation nucleus, only about 2/10 of a micron. That would be comparable to, say, a large virus or small bacterium that's blowing around in the wind. A tiny speck of smoke, things like that. As water builds around it, forming a droplet that could be in a cloud, that could be on the order of 100 times more, from 2/10 to 20 microns. Now, cloud droplets, well, it depends on how the air is moving around. Air moving more vigorously can hold bigger stuff up. I mean, same sort of idea. If we take, say, a piece of paper, if I try a little bit, I can maybe keep that paper in the air a little bit from air blowing. Stronger wind could keep this paper in the air. Very still air, and no, it falls down. Same is true of our cloud droplets. If we have air moving around more, it will keep things up. Very still air, smaller things will fall down. So typical cloud droplet, about 20 microns. Large one up to about 100. Very still air, if these small ones start to fall, then they're so small they basically just evaporate. If it gets to around 300 microns, so getting close to 1/3 of a millimeter, then often that's enough to start falling, but it's pretty small, it's just drizzle. More typical raindrop is on the order of about 2 millimeters. So that far, okay, you can barely see it, but it is visible. And when it gets that big, unless there's a rather strong updraft of air, by the time it gets that big, it is going to fall down. So if our raindrop or snowflake, depending on the temperature, it gets too heavy for the air moving around to hold it up, it'll fall. Besides snow and rain, we can also have sleet. Now, just to make things confusing, sleet is used a little bit differently in England versus US. But over here, we use sleet to mean when we have some raindrops, and these enter colder air and the raindrops freeze. So it'll be little pellets of ice formed by frozen raindrops. Freezing rain happens when you have very cold water, rain is falling through cold air, and then hits a surface below freezing, and it freezes as it lands on the surface. So that will form a coat of ice around things, but it's liquid when it's in the air. Note, both of those are happening with the temperature right around freezing. The air has to have been warm enough to have melted stuff, but then cold again to have freezing. So if the air temperature is right close to freezing, it's pretty tricky to predict exactly. Are we going to have snow? Are we going to have rain? That depends on if they're up in the cloud. This is all basically starting out as snow at cloud level. But if it falls to warmer air, it can melt and become rain. But if then there's colder again, maybe that rain freezes into sleet. Or maybe it hasn't quite frozen yet and then hits the surface and freezes. Telling exactly what's going to happen for the weather when you're right around freezing is quite tricky. Here's an example from a couple years back on campus. We can see some of the more needle-like snow and the rounder pellets of sleet that we had falling on that particular day. Okay, how about stuff that's not falling? Clouds or fog. Both of these are water droplets that have condensed from water vapor up in the air. We call it fog if it's down near Earth's surface, and clouds if it's above. Now, of course, this depends a little bit on where you are. For example, there was one day I was going to the mountains for a hike, and it was kind of a cloudy day, and as I started to get up into the mountains, it was getting foggy. We were getting up into the cloud level. And so from the point of view of up in the mountains, it was fog rather than cloud, which is what it seemed like down at lower levels. And then getting towards the start of the hike, top of the mountain, come out of the top of the clouds. And it's nice and sunny up there. And we head on the hike towards the waterfall. It's going downhill. And right as we get to near the waterfall, here's the top of the clouds. We could hear that waterfall, we could not see it. It was in the fog once more. Again, droplets making up fog or cloud tend to be in the range from about 20 to 100 microns. 100 microns would be 1/10,000th of a meter. Maybe barely visible if you look really close. Turns out that's a good size for scattering light, making rainbows, things like that. How do we make a cloud or fog? Well, we need to have water vapor in the air, and the air being at the dew point. So we've got air, we've got water vapor, suitable temperatures, and we've also got some sort of little specks of things, the condensation nuclei in the air that can stick on. Briefly mentioned before, in addition to stuff like dust and tiny bits of salt when drops of seawater evaporate, there are some chemicals such as dimethyl sulfoxide made by various living things that water sticks to very well. So bits of dimethyl sulfide in the air are great for making clouds. Plankton that release this chemical are actually tending to make clouds above them. Places where we easily have these situations are often foggy. San Francisco has a reputation for being extremely foggy because we've got the ocean there. One, there's plenty of water. Two, that ocean water tends to be cold from the cold currents. And so if warmer air moves out near the ocean, it's going to cool down, it's got plenty of moisture in it, and we're likely to get lots of fog. Again, as air moves around, that's what keeps water droplets from falling, able to keep clouds and fog in the air. They're tiny enough though, if air is very still and starts to fall, typically they evaporate and do not hit the ground. But if they get big enough, then they can fall to the ground and we have rain. Here's an example of it happening. We can also see that my backyard did not have very good drainage. So we'll look more then at types of fog and clouds.